Alright guys, so I had this integral requested. So today I will be walking you guys through how to solve this integral. And I don't just want to jump into the solution and show you guys the actual process. I think it's more valuable if I actually walk you guys through the logical process in deciding the strategy that we use to evaluate this indefinite integral. And again, as I said in a previous video, sometimes the hardest part of evaluating integral is actually figuring out the strategy in which to solve it. So originally I tried to make use of a u substitution, and upon inspection we can see that there isn't really a u substitution that we can make use of that will simplify this into something that we can evaluate easily. So I said, okay, can we simplify this integral? So I tried to simplify this a little bit, and I rewrote this as the negative integral of the square root, and I factor the polynomial inside, difference of squares, so we can factor it like that, all over 1 plus x. And I noticed that we have a 1 plus x here and a 1 plus x here. So I rewrote this. Oh, there should be a dx. I rewrote this as a negative integral. I distributed this square root, which is really just a 1/2 power. It should be minus x. 1/2 all over 1 plus x. And this is technically to the first power. And we can see that we can actually make some simplification right here. This 1 plus x to the 1/2 over 1 plus x to the 1, we can actually write this as the negative integral of 1 minus x to the 1/2 over 1 plus x to the 1/2 dx, which then simplifies to 1 minus x over 1 plus x 1/2 dx. This actually looks a lot more simple. Again, we run into the same problem. There's not really a u substitution that we can use that makes this integral easier. So u substitution didn't work out originally in this part, and even after simplification, we couldn't reduce it to something that we were easily able to integrate, and also we weren't able to make use of a u substitution down here in the simplified form. So usually that means we need to rethink our strategy. So then what I recognized is that we have a square root and a 1 minus x squared. And I'll tell you guys right now, usually when you see this, a square root with a 1 minus x squared, usually that's indicative of a trig substitution. The reason is because we have multiple identities associated with something like this. We have cosine squared plus sine squared is equal to 1. We have tan squared plus 1 is equal to secant squared theta, I believe. I think that's right. So usually we can let x equal tan theta or x equals sine or cosine, either or, and we can make use of these identities to simplify this. So what I recognize is we have a 1 minus x squared. So I decided to try a trig substitution with this. So what I'm going to do is I'm going to let x equal to sine theta. And therefore, whenever we differentiate this with respect to theta, we get cosine theta. And we can go ahead and solve for dx. dx gives us cosine theta d theta. And let's go ahead and substitute these expressions into our integral up here. So I'm going to rewrite this as the negative integral of the square root of 1 minus sine squared theta all over 1 plus sine theta, and then dx, which we determined was cosine theta d theta. And right now you can see that we can make use of that identity that I showed you guys earlier. Right here, 1 minus sine squared theta is really just cosine squared theta. So I'm going to say, let's let this equal the integral of the square root, substitute in for 1 minus sine squared theta. That gives us the square root of cosine squared theta. And let's go ahead and rewrite this stuff. So we have a cosine squared under a square root, and that actually gets rid of the square root and gives us just a cosine. So let's go ahead and rewrite that as cosine. And we have this cosine right here, so it actually becomes cosine squared theta over 1 plus sine theta d theta. So we had square root of cosine squared theta times cosine theta equals cosine squared theta over 1 plus sine theta and then d theta. And now I'm going to use that same trig identity again. And this time I'm going to substitute in for cosine squared theta. So that's just equal to 1 minus sine squared theta, right? So this is equal to the negative integral of 1 minus sine squared theta all over 1 plus sine theta and d theta. And I'm going to make use of the difference of squares up here. We have 1 minus sine squared theta. That's difference of squares. So we can actually factor that. So this is equal to the negative integral of 1 minus sine theta times 1 plus sine theta difference of squares, all over 1 plus sine theta. And now we see that we can nicely cancel out these guys. So all I'm left with is the negative integral of 1 minus sine theta d theta. And this is easy to deal with. So we can just straight up integrate this. We have negative, when we integrate 1, we just get theta. And when we integrate sine theta, we get a negative cosine theta. So this comes out to a positive cosine theta. And this is going to be our answer in terms of theta. But remember that we use this trig substitution up here. X is equal to sine theta. So we can actually use that to solve for theta and plug in right here. So if x is equal to sine theta, then we can take the inverse and say, all right, sine inverse of x is equal to theta. Now we need to find an expression for cosine theta. And let's do something similar. So let's represent our trig substitution by a triangle. So again, we let x equal to sine theta. So if this represents our theta right here, and sine of theta is equal to x, and sine of theta is opposite over hypotenuse, then this can be x and this can be 1. And by Pythagorean theorem, this makes this 1 minus x squared. So now let's use this triangle to determine an expression for cosine theta. So cosine theta is adjacent over hypotenuse, which gives us square root of 1 minus x squared for cosine theta. So let's go ahead and plug this result and this result back into our expression in terms of theta, and let's get our final answer. So we have negative, theta was sine inverse of x, and plus cosine theta, so plus square root of 1 minus x squared. So this is going to be the final answer. So anyway, thanks for submitting this question. Feel free to submit more. I always do my best to answer questions as fast as possible, either with a video or by text or email or whatever. So yeah, thanks for watching. I'll see you guys later.